Good morning, students. So let's start with the today's Google Classroom. So today's Google Classroom, it is about the paper name Physical Chemistry. And the Physical Chemistry, it has a paper number is 8. And we have started the chapter, that is a unit, thermodynamic first. So from the previous Google Classroom, we have studying the various topics from the chapter thermodynamics. So today we study the another important topic from this chapter, that is His law of heat summation and its application. So today we see the His law of heat summation and what are the applications of this law. We have to study in today's Google Classroom. So before to start with this today's Google Classroom, in a previous Google Classroom we have already seen the most important terms which are useful to understand the thermodynamics. So today we also see the another important term, that is His law of heat summation and its application. So let's start with what is meant by the His law of constant heat summation and how it can be studied. His law of constant heat summation, it is also known as His law, or this simply or in shortly His law, is a relationship in a physical chemistry and named after the German Hess. Hess, it is the name of the scientist, a German scientist. According to this law, this law states that total enthalpy change during the complete course of the chemical reaction is the same whether the reaction is made in one step or in several steps. His law stated that the enthalpy change during the complete reaction of the chemical reaction is the same as a reaction is made in a single step or in several steps or in the multiple steps. So it is a simple statement about the Hess law. We see the another points about this Hess law also. Hess law is now understood as an expression of the principle of conservation of energy, also expressed in first law of the thermodynamics, and the fact that the enthalpy of chemical process is independent of the path taken from the initial to the final state. The reaction enthalpy changes can be determined by the calorimetry for many reactions. The values are usually stated for the process with the same initial and the final temperature and the pressure. Although the conditions can vary during the reaction, His law can be used to determine the overall energy required for the chemical reaction when it can be divided into the synthetic steps that are individually easier to characterize. This affords a completion of the standard enthalpies of the formation that may be used as a basis to design complex synthesis. So what do you mean by His law states? His law states that change in enthalpy in a chemical reaction, that is the heat of reaction at a constant pressure, is independent of the pathway between the initial and the final states. In other words, if the chemical change takes place by the several different routes, overall enthalpy change is the same, regardless of the route by which a chemical change occurs, provided the initial and the final conditions are the same. So this His law also allows the enthalpy change delta H for the reaction to be calculated even when it cannot be measured directly. This is accomplished by the performing the basic uh, algebraic operations based on the chemical equations reactions using previously determined values. So this all his law it is summarized in these two uh, slides, or the definition or the statement about this like it is again given, that is for the any chemical reaction at an standard conditions, standard enthalpy change is the same sum of the standard molar enthalpies of the formation of the products multiplied by its coefficient in the balanced chemical equation minus the corresponding sum of the reactants. So this is the equation about the Hess law. Then the Hess law heat of summation state that enthalpy change for the reaction is the same whether it occurs by the one step or the any other hypothetical series of the state. So they have given the example about this Hess law, that is the reaction first, second, and the third, and they have given the delta H. They have given the delta H about is the state of the function. So all the heat is law of summation is given in this slides also. Okay, thank you.